bias and variance. Bias is when you're missing information in your sample that is accurately predictive of the world. Okay? Variance is when you are treating patterns in your sample incorrectly as if they apply to the world. Okay? So, when a system is biased, it is underfitted to the data. It's not sensitive enough. It's not picking up on all the patterns it should pick up on. When a system is undergoing variance, it's overfitted to the data. It's picking up on patterns that it shouldn't be using to predict the world at large. Does that make sense so far? Yes? Now notice there's a trade-off relationship, and machine learning is bedeviled by this, by the way, because if I tried, how do I overcome bias? I'll make my machine more sensitive, more powerful. I'll make my neural networks capable of more parametric space, picking up more complex patterns. What happens when I do that? I'm increasing and increasing the chances I'll overfit to the data and I'll fall into variance. Oh, so what I'll do is I'll have to somehow disrupt that. So what do you see actually in machine learning? You see at an institutional level, opponent processing going on. So what they're doing is they're building increasingly more powerful machines that are increasingly sensitive at picking up patterns, and then they have to do an opposite, an opponent process. They do disruptive strategies. They will throw in noise, will they turn off half the network, drop out, or noise. Why are they doing this? When they throw in the noise, when they do the disruptive strategy, it loosens the overfitting on the data. And this lines up with a lot of what Julian was talking about. So what you basically do is you make the system stupid for a bit. It's less sensitive. It stops picking up on the too many patterns, and it gets released to make better predictions about the world. But you don't want to make it too stupid for too long, because then what you have is a stupid machine. And that's not good either.